Imagine being the person who discovers the first evidence of intelligent life beyond Earth. In 1977, astronomer Jerry Emmon experienced this cosmic heartbeat moment when he spotted a signal perfectly matching what scientists expected alien communication to look like. Writing, "Wow," on the printout before watching it vanish, never to return despite decades of searching. The wow signal represents our closest brush with answering whether we're alone in the universe. Today, we're examining compelling evidence for and against its extraterrestrial origin, including a breakthrough 2024 study that might finally explain this enduring cosmic mystery, with profound implications for every future SETI effort. The silent universe? What if the sound of alien contact has already reached Earth, but we missed it? What if, among the countless radio signals we detect every day, one carried a message from another civilization, and we simply failed to recognize it? The universe is vast beyond comprehension. Our Milky Way galaxy contains between 100 and 400 billion stars within a universe housing at least 100 billion galaxies. Humans have pondered the existence of other intelligent life among these stars since antiquity. Ancient Greek philosophers like Epicurus speculated about infinite worlds with their own inhabitants, planting seeds of curiosity that would grow into the scientific searches we conduct today, a continuous thread of wonder stretching across millennia. The mathematical probabilities suggest life should be abundant. In 1961, astronomer Frank Drake formulated an equation estimating the number of communicative alien civilizations in our galaxy. Even conservative calculations indicate we shouldn't be alone. Yet in 1950, physicist Enrico Fermi posed a question that became known as the Fermi Paradox. Where's everybody? This stark contradiction between probability and evidence continues to challenge our understanding. This cosmic silence presents a puzzle. Perhaps civilizations destroy themselves before developing interstellar communication, or intelligent life might be extraordinarily rare. Alternatively, civilizations may be reaching out while we listen in the wrong ways. The formal search for extraterrestrial intelligence began in 1960 when Frank Drake directed a 26-meter radio telescope toward two nearby stars, Tau Ceti and Epsilon Eridani. His Project Ozma established methodologies that guide SETI efforts today. Though Drake detected nothing unusual during his 150 hours of listening, he pioneered a scientific approach that transformed ancient wonderings into empirical investigation. Radio waves serve as ideal cosmic messengers for several reasons. They travel at light speed, penetrate cosmic dust and gas, carry complex information across vast distances with minimal energy, and certain frequency ranges exist where space itself is quieter, creating natural windows for detection. Scientists made educated guesses about which specific frequencies aliens might use. In 1959, physicists Giuseppe Cocconi and Philip Morrison proposed in Nature that advanced civilizations would likely choose the 1420 MHz frequency, the natural emission frequency of hydrogen, the most abundant element in the universe. This hydrogen line falls within a relatively quiet part of the radio spectrum called the waterhole. The reasoning was elegant. Cosmic communicators would select a frequency with universal significance, a cosmic telephone number that any scientifically advanced civilization would recognize. The hydrogen line functions as a universal meeting point, analogous to telling someone, "Meet me at the only lighthouse on the coast." By the 1970s, multiple SETI projects were scanning the skies, albeit with significant technological limitations. Modern radio telescopes analyze millions of frequency channels simultaneously, but early researchers monitored only a few channels at once, often reviewing computer printouts manually to identify anomalous signals. Ohio State University operated one such project using a radio telescope called Big Ear. Built in 1963, this telescope consisted of a large flat aluminum reflector, a curved reflector, and radio receivers on towers. Rather than tracking objects across the sky, Big Ear remained stationary, using Earth's rotation as its scanning mechanism, meaning any point in the sky remained in view for exactly 72 seconds. Originally dedicated to mapping radio sources, Big Ear had been repurposed by 1977 to search for extraterrestrial signals. Dr. Jerry Emmon, a professor volunteering with the project, analyzed the telescope's data. On August 15, 1977, while pointed toward Sagittarius, the telescope recorded signal strengths on a printout. Most columns showed typical background noise. The next day, Dr. Emmon discovered something remarkable, a strong signal that appeared intensified. then diminished within the expected 72-second window. Its characteristics matched theoretical predictions for artificial transmission. Emmons circled the characters representing the signal and wrote, "Wow," in the margin, giving the detection its famous name. When the WOW signal appeared, SETI occupied a somewhat marginal position in mainstream science. Despite solid theoretical foundations, the search for alien signals was often viewed skeptically. The WOW signal changed this perception by providing evidence that couldn't be easily dismissed, a detection aligning perfectly with theoretical predictions for extraterrestrial communication. This discovery legitimized SETI for many scientists. If such a signal could appear once, detection might occur again, making the search worthy of greater resources and scientific attention. In subsequent years, SETI programs expanded into projects like the Allen Telescope Array and Breakthrough Listen, which now monitor billions of frequency channels simultaneously. What exactly happened on that summer night in 1977 that transformed our perspective on cosmic communication? To understand the significance of the WOW signal, we must examine what made it so unusual and why. Nearly 5 decades later, scientists continue debating its origin. 72 seconds that changed everything. What makes one signal among millions worth writing "wow" next to? In the vast sea of cosmic radio noise, astronomers spend countless hours searching for patterns that might indicate intelligence rather than natural phenomena. Most days yield nothing but the random static of stars, galaxies, and other celestial objects. But sometimes, something unusual appears, something that makes an astronomer stop, look twice, and reach for a pen. August 16, 1977, began as an ordinary day for Dr. Jerry Emmons. The astronomer volunteered his time with Ohio State University's SETI program, analyzing computer printouts from the Big Ear radio telescope. The work was methodical and often monotonous. Big Ear had been scanning the skies for years, producing endless pages of data that needed human eyes to interpret. The printouts contained columns of alphanumeric characters, numbers and letters representing signal intensities at different frequencies. Most pages showed nothing but ones and twos, indicating the low-level background radiation that permeates the universe. Emmons settled into his routine at the observatory, working through the previous night's observations. Each number and letter on the printout represented the strength of radio waves detected at specific frequencies, with higher numbers and letters indicating stronger signals. The pages contained 50 channels of data across the frequency range being monitored. As he scanned the columns, he expected to see what he always saw: the consistent pattern of low-intensity signals that indicated normal cosmic background noise. The monotony of the printout stretched before him, an unbroken sea of unremarkable values. Then suddenly, amid the quiet wilderness of ones and twos, something extraordinary leapt from the page. Near the middle of one sheet was a sequence that stood out dramatically: 6EQUJ5. Unlike the surrounding characters, this sequence showed a signal that began at intensity 6, rose to E, then Q, peaked at U, the highest value in the system, then decreased through J and 5, before disappearing altogether. The pattern formed a perfect bell curve, like a perfectly tuned symphony that crescendos then fades into silence. Exactly what would be expected from a fixed, point source signal passing through the telescope's reception field as Earth rotated. Looking at those 6 characters, Emmons immediately recognized their significance. This wasn't random noise or a momentary spike. The sequence showed a coherent signal with a clear pattern of increasing and then decreasing intensity. It was precisely what SETI researchers had theorized an artificial signal might look like. The signal was strong, about 30 times more powerful than the background noise, and extremely focused in frequency. Emmons' heart raced as he stared at the sequence. His hand trembled slightly as he reached for his red pen. Could this be the moment? The discovery that changes everything? Without overthinking his reaction, he wrote, "Wow," in the margin next to the sequence. A simple, human response to a potentially extraordinary discovery. He circled the characters, adding exclamation points for emphasis, his mind racing with possibilities and questions that would keep him awake for nights to come. The signal's most compelling feature was its 72-second duration, precisely the amount of time the Big Ear telescope would observe a fixed point in space as Earth rotated. This perfect timing matched theoretical predictions for an artificial signal from a stationary cosmic source and was another characteristic that made Emmons take notice. The signal appeared at approximately 11:16 p.m. Eastern Time on August 15th. a seemingly random moment that would become a landmark in SETI history. It came through only one of the telescope's 2 feed horns, suggesting it originated from a specific direction in space rather than being widespread interference. The signal was detected at a frequency of 1420.4556 MHz, remarkably close to the hydrogen line at 1420.4058 MHz, the frequency that SETI researchers had long considered the most logical choice for interstellar communication. Emin's first thought was to rule out equipment malfunction or data errors. He checked the surrounding data for similar patterns, but found none. The signal was isolated and unique. Equipment logs showed no technical issues. The Big Ear telescope was functioning normally before, during, and after the signal detection. He also considered whether the signal might represent interference from Earth-based sources. Could it be a reflection from a satellite? A military transmission? An aircraft passing overhead? Several factors argued against these explanations. The signal's frequency was in a protected band where terrestrial transmissions were prohibited. Its perfect 72-second duration matched an astronomical source rather than a passing satellite or aircraft. Its precise frequency characteristics didn't align with known types of human-generated interference. What made the sequence 6EQUJ5 stand out so dramatically was its strength and its contrast with everything else recorded that night and throughout Big Ear's operational history. The telescope had been scanning the skies since 1963, producing thousands of pages of data, and nothing like this had ever been seen before. The signal appeared in only one frequency channel, approximately 10 kHz wide. This narrow bandwidth was another characteristic consistent with artificial origin rather than natural phenomena, which typically produce broader emissions across multiple frequencies. Natural radio sources like pulsars and quasars emit across wider frequency ranges. This signal was focused, like a carefully tuned radio transmission. In the days that followed, Emin shared his discovery with other SETI researchers, including the director of the Ohio State SETI program, Dr. John Krause. They reviewed the data together, confirming the signal's unusual characteristics. The team quickly checked to see if the telescope had detected anything similar in subsequent observations of the same region of sky. They found nothing. The signal had appeared once and never again. This one-time appearance would become one of the most puzzling aspects of the WOW signal. If it was a transmission from an extraterrestrial civilization, why was it not repeated? If it was a natural phenomenon, why couldn't it be observed again? These questions would fuel decades of debate and follow-up observations. But to understand why this particular signal was so extraordinary, we need to decode what those 6 characters actually meant. What information was encoded in 6EQUJ5? And why did this specific sequence so perfectly match what scientists expected an alien transmission to look like? Decoding 6EQUJ5. How could 6 ordinary characters represent potential first contact with an alien civilization? To appreciate the significance of the WOW signal, we need to understand exactly what those 6 characters meant and why they created such excitement among astronomers. The Big Ear radio telescope used a remarkably straightforward system to record signal intensities. Unlike modern telescopes that capture and store raw data for later processing, Big Ear's 1970s computer system had limited memory and processing power. To cope with these constraints, the telescope's designers created an ingenious compression method that converted radio signal strengths into a simple alphanumeric scale. The system functioned like an efficient cosmic shorthand. As the telescope scanned the heavens, it continuously measured incoming radio waves and translated their intensities into readable characters. Numbers 1 through 9 represented the lowest intensities, followed by letters A through Z for stronger signals. This provided 35 distinct values to represent the range of signal strengths. The value 1 indicated just above the background noise level, while Z would signify an extraordinarily powerful signal. In an era when a typical computer might have less processing power than today's digital wristwatch, this elegant solution allowed astronomers to review vast amounts of cosmic data at a glance. Each morning, the computer would print out these characters on continuous feed paper, creating long columns of numbers and occasional letters. Volunteer astronomers like Jerry Emin would then visually scan these printouts, looking for unusual patterns among the typically random distribution of low values. Let's break down what the sequence 6EQUJ5 actually represented. Each character showed the signal strength at that moment as Earth's rotation carried the radio source through the telescope's field of view, like musical notes building to a crescendo before fading away. 6. A signal 6 times stronger than the background noise level. 8. the 14th letter of the alphabet, representing a signal 14 times stronger than background. Q, the 26th letter, indicating intensity 26 times above background. U, the 30th letter, showing the peak intensity at 30 times background level. J, the 19th letter, as the signal began to fade. 5, back to 5 times background as the signal left the telescope's field of view. This progression formed a perfect bell curve, starting relatively strong, increasing steadily, peaking at U, then declining symmetrically. This pattern wasn't random noise or interference, which would show erratic variations. Instead, it displayed exactly the profile scientists would expect from a fixed radio source moving through the telescope's reception pattern due to Earth's rotation. The peak value of U represented a signal approximately 30 times stronger than the cosmic background noise. The crucial distinction was the signal's narrowband nature. The WOW signal was concentrated in an extremely narrow frequency range, around 10 kHz wide. Natural radio sources typically emit across much broader frequency ranges, spreading their energy across the spectrum. This narrow focus made the signal's strength truly remarkable. It concentrated its energy in a very specific frequency, making it stand out dramatically from the background. This signal-to-noise ratio was unprecedented in the telescope's operational history. Big Ear had been scanning the skies since 1963, recording millions of measurements, and nothing approaching this intensity in such a narrow frequency band had ever been detected. As Earth rotates, a radio telescope's reception pattern, called a beam, sweeps across the sky. If a fixed radio source passes through this beam, the recorded signal strength will increase as the source enters the most sensitive part of the beam, peak when centered, and decrease as it exits, creating the bell curve seen in 6EQUJ5. This pattern matched precisely what would be expected from a fixed point source in space, rather than a moving source like a satellite or a momentary equipment glitch. When comparing the WOW signal to known natural radio sources, several distinctions become apparent. Pulsars produce regular, repeating pulses rather than a single event. Quasars and radio galaxies emit across broad frequency ranges. Solar flares and other stellar phenomena typically show broader bandwidth and different intensity patterns. Human-made signals also fail to match the WOW profile. Satellites typically transmit at different frequencies, often with modulation patterns that would appear as variations in the signal strength. Additionally, the frequency of the WOW signal, near 1420 MHz, fell within a protected band where terrestrial transmissions were prohibited internationally. What made the signal particularly compelling to SETI researchers was how perfectly it aligned with theoretical predictions for artificial transmissions. Years before the WOW signal, scientists had developed a profile of what an extraterrestrial signal might look like. They predicted: 1. It would likely use the hydrogen line frequency, 1420 MHz, as a universal reference point. 2. It would be narrowband to maximize detection potential. 3. It would be strong enough to stand out from background noise. 4. It would likely appear as a steady signal rather than complex modulation. The WOW signal checked every box on this theoretical profile. It appeared at almost exactly the hydrogen line frequency, was extremely narrowband, significantly stronger than background noise, and showed a steady intensity pattern consistent with a continuous transmission. This alignment with predicted characteristics is why many astronomers considered the WOW signal to be the strongest candidate ever detected for an artificial extraterrestrial transmission. The statistical improbability of a natural phenomenon producing such a signal added to its significance. The combination of the precise frequency, narrow bandwidth, high intensity, and perfect duration made a natural explanation increasingly unlikely. The signal's frequency held an even more compelling clue to its potential origin. Why would a signal appear at almost exactly the frequency that scientists had long theorized would be the universal calling card for intelligent civilizations? The hydrogen line, cosmic calling frequency. Why would an advanced civilization choose the precise frequency detected in the WOW signal? Of all the countless radio frequencies that span the electromagnetic spectrum, why would a potential extraterrestrial transmission appear at 1420.4556 MHz? This specific frequency represents one of the most compelling aspects of the WOW signal mystery, and understanding its significance requires exploring some fundamental astrophysics. The hydrogen line, precisely 1420.405751777 MHz, represents one of the most important frequencies in astronomy. This specific frequency is produced when a hydrogen atom, the simplest and most abundant element in the universe, undergoes a specific quantum transition. A hydrogen atom consists of one proton and one electron. Both the proton and electron have a property called spin, somewhat analogous to a spinning top. In a hydrogen atom, these particles can spin in the same direction, parallel, or in opposite directions, anti-parallel. When a hydrogen atom transitions from having parallel spins to anti-parallel spins, it releases energy in the form of radio waves at exactly 1420.405751777 MHz. This emission serves as a cosmic fingerprint of hydrogen, uniquely identifying the element across the universe. While this transition occurs approximately once every 10 million years per atom, hydrogen's extraordinary abundance throughout space makes these emissions detectable everywhere. Astronomers refer to this emission as the hydrogen line, or 21-centimeter line, referring to the wavelength. This frequency functions essentially as a radio channel all civilizations would tune into by default. Any technologically advanced civilization capable of radio astronomy would inevitably discover and study this frequency. It serves as a universal constant, recognizable to any scientifically advanced species regardless of their biology, language, or cultural development. The hydrogen line creates a universal meeting point in the electromagnetic spectrum. Like ancient human civilizations that used prominent geographical features as gathering places, the hydrogen line provides a cosmic landmark that transcends biological and cultural differences. Any civilization attempting interstellar communication would naturally gravitate toward frequencies that would attract attention across the cosmos. The universality of hydrogen underpins its importance for communication. Stars form from hydrogen, planets contain hydrogen, and hydrogen exists throughout the observable universe. Even civilizations that evolved in dramatically different environments would recognize hydrogen's fundamental importance in its emission frequency. The hydrogen line has intrinsic cosmic significance that transcends arbitrary frequency choices. Another critical reason for selecting this frequency involves the radio environment of space. The region around the hydrogen line is remarkably quiet in terms of cosmic radio emissions. Astronomers refer to the area between 1,400 to 1,700 MHz as the water hole, a quiet zone with minimal interference from natural cosmic sources. This name references both the frequencies of hydrogen, H, and hydroxyl, O, which form water, H2O, while alluding to watering holes where diverse animal species gather peacefully on the African savanna. This quiet zone creates ideal conditions for interstellar communication. Just as you would choose a quiet room for an important conversation rather than a noisy street corner, an advanced civilization would likely select frequencies with minimal natural interference. The region around the hydrogen line provides exactly this quiet background, allowing signals to stand out more clearly across vast distances. The WOW signal's frequency was recorded as 1420.4556 MHz, remarkably close to the hydrogen line. This proximity is striking and unlikely to be coincidental. The difference between the two frequencies is only about 0.05 MHz, or about 0.0035% variance. This slight difference might seem puzzling, but there's a scientific explanation that strengthens the signal's potential significance. The small frequency difference could be explained by the Doppler effect, the same phenomenon that causes a siren to change pitch as an ambulance passes. If the source was moving relative to Earth, the frequency would shift slightly. A source moving toward Earth would produce a higher frequency, blue shift, which is what we observe with the WOW signal. The slightly higher frequency suggests a relative motion toward Earth at approximately 36 kilometers per second, well within the range of typical stellar motions in our galaxy. Alternatively, the transmission might have been deliberately offset from the exact hydrogen line frequency. A civilization might transmit near, but not exactly at the hydrogen line to indicate artificial origin. Natural hydrogen emissions occur precisely at the hydrogen line, so a slight offset might serve as a marker saying, this is an intentional signal. What makes the frequency aspect particularly compelling is that SETI scientists had predicted, before the signal's detection, that the hydrogen line would be the most logical frequency for first contact. In their 1959 paper, physicists Giuseppe Cocconi and Philip Morrison specifically proposed 1420 MHz as the most likely frequency for alien transmissions. The signal's appearance at almost exactly this frequency, 18 years after this prediction, significantly increased its credibility. Dr. Frank Drake, who conducted the first modern SETI experiment in 1960, also focused his search on frequencies near the hydrogen line. By the 1970s, the international community had recognized this frequency range's importance, designating it as a protected band where terrestrial transmissions were restricted. The signal's frequency alignment with theoretical predictions is extraordinary. Scientists had essentially said, if aliens try to contact us, they'll likely use this specific frequency, and then a signal appeared at almost exactly that frequency. With both intensity and frequency matching theoretical predictions, scientists needed to pinpoint exactly where in the vast cosmos this signal originated. If they could determine its source, they might direct more powerful telescopes toward that region, potentially receiving additional transmissions or identifying unusual stellar systems that might harbor advanced civilization. What cosmic neighborhood might have sent us a message? With the WOW signal's unusual strength and frequency characteristics established, astronomers faced another critical question. Where exactly did it come from? Pinpointing the signal's origin would be essential for any follow-up observations and for assessing possible sources, whether natural or artificial. The Big Ear radio telescope used a fixed design rather than a steerable dish like many modern radio telescopes. The entire structure remained stationary, using Earth's rotation to scan the sky. This design choice came from budget constraints. Moving a large radio telescope requires complex mechanisms. Instead, Big Ear employed large, flat reflectors that bounced incoming radio waves to a curved reflector, which then focused them onto receiver horns mounted on towers. This fixed design meant the telescope observed a strip of sky approximately 20 minutes wide as Earth rotated. Any celestial object would take about 72 seconds to pass through the telescope's reception beam. While limiting what portions of the sky could be observed on any given day, it allowed for systematic scanning of the heavens over time as Earth orbited the Sun, gradually changing which part of the sky was visible. The telescope used two separate feed horns, creating two beams that observed slightly different parts of the sky. These dual beams helped distinguish genuine astronomical signals from local interference. This design created a celestial puzzle in pinpointing the WOW signal's origin. The signal appeared in only one of the two horns, which created ambiguity about its exact position. Since they didn't know which of the two horns detected the signal, there were two possible coordinate locations, leaving astronomers with a mystery that has complicated all subsequent investigation efforts. Despite this ambiguity, the telescope's design still allowed astronomers to calculate the signal's celestial position with reasonable precision. They determined that the signal came from somewhere in the constellation Sagittarius. The position in Sagittarius is particularly interesting. This constellation lies toward the center of our Milky Way galaxy, a region rich with stars and potentially habitable systems. However, the WOW signal coordinates don't point directly at the galactic center but rather to a region slightly offset from the densest part of the galactic plane. This location northwest of the globular cluster M55 places the signal origin in a relatively uncrowded region of sky compared to the galactic core. Globular clusters like M55 are spherical collections of hundreds of thousands of ancient stars, tightly bound by gravity. M55 itself is approximately 17,600 light-years from Earth and contains stars nearly as old as the universe. The WOW signal didn't come from the cluster itself but from a region of space near it from our perspective. The exact coordinates were calculated as a declination, similar to latitude, of -26 degrees 57 feet and one of two possible right ascension values, either 19 hours 22 minutes 24.64 seconds or 19 hours 25 minutes 17.01 seconds. What makes this location interesting is that it contains numerous stars similar to our Sun, including both older stars and star-forming regions where younger stellar systems might host developing planets. If an extraterrestrial civilization were transmitting the signal, it would likely come from a star system with characteristics that could support life as we understand it. After calculating these coordinates, astronomers cross-reference them with star catalogs to identify potential source stars. This process revealed several candidates at different distances from Earth. Some of these stars are similar to our Sun in size and temperature, making them potential hosts for habitable planets. However, at the time of the WOW signal's detection in 1977, astronomers knew relatively little about exoplanets. The first confirmed planet orbiting another star wasn't discovered until 1992. With modern astronomical data, we now know this region contains many more interesting objects than were catalogued in the 1970s. Subsequent surveys have identified additional stars, including some with confirmed exoplanets. The region also contains various gas clouds, distant galaxies, and other radio sources that weren't well documented when the WOW signal was detected. What's particularly notable about this region is that it lacks any unusual celestial objects that could explain the signal's unique characteristics. There are no pulsars, quasars, or other known powerful natural radio sources at exactly these coordinates that could produce such a strong, narrowband emission at the hydrogen line frequency. The region contains fairly typical stars and interstellar medium for that part of the galaxy. This absence of obvious natural sources has strengthened interest in the signal's potential artificial origin. If natural phenomena cause the signal, astronomers would expect to find an unusual astronomical object at its coordinates. The fact that the region appears unremarkable by astronomical standards leaves the door open for both undiscovered natural phenomena and potential artificial transmissions. The signal's origin coordinates have been observed repeatedly since 1977 using increasingly sophisticated radio telescopes. Despite dozens of follow-up observations, nothing matching the characteristics of the WOW signal has been detected again at those coordinates. This failure to redetect the signal presents a significant challenge to determining its nature. If it were a transmission from an alien civilization, we might expect to detect it again. However, there are explanations for a one-time detection. The transmitter might use a rotating beam that only occasionally points toward Earth. The civilization might transmit only periodically to conserve energy. The original signal might have been a brief, specific transmission rather than a continuous beacon. In 2020, amateur astronomer Alberto Caballero identified a Sun-like star called 2MASS 19281982-2640123 in the WOW signal region that represents a potential candidate for hosting an advanced civilization. Located approximately 1,800 light-years away, this G-type main sequence star resembles our Sun and could potentially host habitable planets. However, it's just one of many similar stars in the region, and there's no direct evidence linking it to the signal. With the signal's characteristics and origin mapped, scientists face their greatest challenge, determining whether it was truly extraterrestrial or had a more mundane explanation. The signal's strength, frequency, and pattern were compelling, but without a repeat detection, could scientists rule out terrestrial interference or natural phenomena? The hunt for explanations. Terrestrial interference? Could the most promising alien signal actually have originated from Earth? This question has haunted the WOW signal investigation since its discovery. In science, extraordinary claims require extraordinary evidence, and claiming extraterrestrial origin demands eliminating all terrestrial explanations first. This methodical process of elimination represents one of the most important aspects of the WOW signal analysis. When astronomers consider potential sources of radio interference, they must investigate human technologies ranging from military radar systems and satellites to aircraft transponders and television broadcasts. Earth's radio environment is filled with signals that could potentially create false positives for SETI researchers if they appeared at the right frequency with the right characteristics. After the WOW signal's detection, researchers began systematically examining every known terrestrial technology that might have produced it. Military installations near the observatory were an obvious first suspect. Researchers contacted military authorities to determine if any classified operations might have used frequencies near the hydrogen line. Military representatives confirmed no such transmissions were authorized in that frequency range. Even classified operations would need to adhere to international frequency allocations to prevent interference with scientific communications. The hydrogen line frequency was specifically protected by international agreement for astronomical observations. Satellites represented another potential source of interference. The Ohio State team carefully checked orbital data for all known satellites that might have been above the horizon during the observation. None matched both the timing and potential frequency of the WOW signal. The signal's characteristics argued against satellite origin. A passing satellite would create a signal that either lasted longer than 72 seconds or showed Doppler shifts as it moved relative to Earth. The WOW signal exhibited neither of these characteristics. Its clean 72-second duration perfectly matched what would be expected from a fixed astronomical source as Earth rotated. Aircraft passing near the observatory were also considered. However, aircraft transponders generally use frequencies around 1030 MHz and 1090 MHz, well away from the hydrogen line. Additionally, an aircraft would produce a signal either shorter or longer than the observed 72 seconds, depending on its flight path relative to the telescope's beam. Ground-based radio transmitters face several obstacles as explanations. The Big Ear telescope was specifically designed with ground shields to block terrestrial signals. The observatory was deliberately located in a radio-quiet area away from major population centers. Most critically, the frequency of 1420 MHz fell within a protected band specifically designated for radio astronomy, with international telecommunications agreements prohibiting terrestrial transmissions at this frequency. As each potential explanation was systematically ruled out, researchers grew increasingly perplexed. Every familiar source of interference seemed incompatible with what they had observed, leaving them with a genuine astronomical mystery that defied conventional explanation. Technical aspects of the signal further complicated terrestrial explanations. Most human-made radio transmissions use modulation to carry information, variations in amplitude, frequency, or phase that encode data. The WOW signal showed no signs of such modulation, appearing instead as a continuous emission at a single, stable frequency, more like a beacon than a communication signal carrying information. The signal's extremely narrow bandwidth also contradicted terrestrial origin theories. Most human transmissions spread across a range of frequencies, either deliberately to carry more information or unintentionally due to technological limitations. The WOW signal was concentrated in an extremely narrow band, approximately 10 kHz wide or less, typical of astronomical sources but unusual for human-made transmissions of that era. Weather phenomena were quickly dismissed. Lightning and atmospheric events typically occur across broad frequency ranges and last for very brief periods, milliseconds rather than seconds. Nothing in Earth's atmosphere could produce a narrowband signal lasting exactly 72 seconds. The possibility of reflection was also analyzed. Could a ground-based signal have bounced off the moon or space debris? This explanation was found unlikely because reflected signals generally become diffuse and weakened, not concentrated and strong like the WOW signal. The precise match to the hydrogen line frequency would also be an extraordinary coincidence. After exhausting all known terrestrial possibilities, researchers faced a striking conclusion. They could identify no Earth-based technology capable of producing the exact characteristics observed. The combination of frequency, duration, intensity pattern, and narrow bandwidth defied explanation in terms of human technology circa 1977. This absence of a convincing terrestrial explanation doesn't automatically prove extraterrestrial origin, but it elevates the signal's status as an authentic astronomical phenomenon rather than local interference. Scientists must always consider unknown human activities, equipment malfunctions, or rare atmospheric effects. However, after 4 decades of investigation, no terrestrial explanation adequately accounts for all the signal's characteristics. The thoroughness of this investigation process demonstrates the scientific rigor applied to the WOW signal analysis. Researchers spent years methodically evaluating and eliminating terrestrial possibilities, following the scientific maxim attributed to Carl Sagan: extraordinary claims require extraordinary evidence. While eliminating terrestrial explanations doesn't constitute proof of extraterrestrial origin, it does move the signal into the category of genuine astronomical mysteries worthy of continued investigation. If not from Earth, could the signal still have a natural explanation rather than an artificial one? The cosmos contains many strange and energetic phenomena, from pulsars and quasars to more exotic objects. This possibility led scientists to explore natural cosmic explanations that might account for the signal's distinctive characteristics. Natural cosmic phenomena. The Comet Hypothesis. Could comets explain the signal that stumped astronomers for decades? Nearly 40 years after the WOW signal detection, an alternative natural explanation emerged that challenged the extraterrestrial hypothesis. This new theory focused not on distant stars or alien civilizations, but on a much closer cosmic neighbor: comets. In 2016, astronomer Antonio Paris, a professor at St. Petersburg College in Florida, along with his colleague Evan Davies, published a paper proposing a radical new explanation for the WOW signal. Their hypothesis centered on hydrogen clouds surrounding comets, specifically 2 periodic comets designated 266P Christensen and 335P Gibbs. Paris suggested that these hydrogen-rich comets might have been in the right position during the 1977 observation to produce a signal matching the characteristics of the WOW detection. The core of the comet hypothesis was elegantly simple. Comets, essentially dirty snowballs, composed of ice, dust, and various compounds, generate hydrogen clouds as they approach the sun and their ice sublimates. These clouds emit radio waves at precisely 1420 MHz, the same frequency as the WOW signal. Paris and Davies calculated that Comet 266P Christensen would have been near the WOW signal coordinates on August 15, 1977, with Comet 335P Gibbs passing through the same region within a relevant time frame. The alignment seemed perfect. Comets in the right celestial location, emitting hydrogen at the detected frequency, moving through the telescope's field of view in ways that might explain the 72-second duration. These hydrogen emissions, though typically faint, comparable to detecting a whisper from miles away, could theoretically produce detectable signals when concentrated enough. To test his theory, Paris launched a crowdfunding campaign for follow-up observations. In 2017, as Comet 266P Christensen approached the same sky region, Paris detected hydrogen signals at frequencies close to the hydrogen line. He published these findings, suggesting they supported the Comet Hypothesis as the solution to one of SETI's most enduring mysteries. The media erupted with excitement. Headlines blazed across science publications and mainstream news outlets. Wow! Mystery signal from space finally explained. The public imagination was captivated by this seemingly perfect resolution. Not aliens after all, but something far more mundane yet scientifically satisfying. Comment sections filled with equal parts disappointment and relief as readers processed that the iconic signal might have such a simple explanation. However, the astronomical community's response quickly dampened this enthusiasm. Several experienced radio astronomers and SETI researchers identified fundamental problems with the comet explanation. Their criticisms focused on technical inconsistencies between comet emissions and the WOW signal's characteristics. The most damning critiques centered on the signal's bandwidth, intensity, and pattern. The WOW signal was extremely narrowband, about 10 kHz, while cometary hydrogen emissions would be broadened by gas molecule motion to span hundreds of kilohertz. The Big Ear telescope had observed thousands of comets during its operational lifetime without detecting similar signals. Technical aspects of the telescope design, particularly its feed horn switch, alternating positions every 10 seconds, would have made a continuous signal from a moving comet appear discontinuous. Yet the WOW signal showed no such pattern. Most critically, hydrogen emissions from comets would be far too weak to produce a signal 30 times stronger than background noise. Jerry Emin, who discovered the WOW signal, joined other researchers in publishing a detailed response outlining these flaws. Seth Shostak of the SETI Institute summarized many astronomers' objections, noting that while interesting, the hypothesis failed to account for the signal's unusual characteristics. The odds that a comet would be lined up with that beam at that moment, and that the comet would have hydrogen at just the right velocity relative to Earth, are extremely small, he explained. Despite these scientific objections, Paris's hypothesis served an important purpose. It renewed interest in the WOW signal and demonstrated the scientific process in action, proposing hypotheses, testing them, and subjecting results to peer evaluation. The debate highlighted difficulties in analyzing one-time signal detections, where researchers must rely on theoretical models and historical data rather than reproducible observations. By 2018, the scientific consensus had largely rejected the comet hypothesis. Cometary hydrogen emissions simply didn't match the WOW signal's profile in bandwidth, strength, or duration. This conclusion didn't automatically validate the extraterrestrial hypothesis, but it eliminated one of the most prominent natural explanations proposed since the signal's discovery. The comet debate illustrates how scientific investigations progress through proposal, testing, and critical analysis. Even unsuccessful hypotheses contribute valuable insights and lead to refined research directions. While ultimately not widely accepted, the comet explanation advanced our understanding of both cometary emissions and the unique characteristics that make the WOW signal so puzzling. With terrestrial and comet explanations falling short, a 2024 breakthrough study proposed a new natural explanation that might finally solve the mystery. This latest theory would approach the signal from an entirely different perspective, examining rare physical processes in the interstellar medium that could potentially account for all the signal's unusual characteristics. The 2024 breakthrough, hydrogen cloud maser theory, has a team of astronomers finally solved the 47-year-old cosmic mystery? In August 2024, researchers from the Planetary Habitability Laboratory announced a potential breakthrough in understanding the WOW signal using data from the now collapsed Arecibo Observatory. This new research offers a natural explanation that might account for all the signal's unusual characteristics while revealing a previously unknown astrophysical phenomenon. The research team, led by Abel Mendez, analyzed archival Arecibo data and conducted new observations focusing on similar narrowband emissions near the hydrogen line. Their hypothesis represents a radical departure from previous explanations. Rather than alien technology, Earth-based interference, or comets, they propose that the WOW signal resulted from a rare natural process involving cold hydrogen clouds in interstellar space. Their theory centers on a phenomenon called stimulated emission, the same quantum process that makes lasers work. In normal conditions, hydrogen atoms in space spontaneously emit radiation at the 1420 MHz frequency through random quantum transitions. However, under certain conditions, these atoms can be stimulated to emit radiation in a coordinated way, creating a sudden, powerful, and highly focused burst of radio waves at precisely the hydrogen line frequency. The mechanics of this astronomical light show work like this. A star positions itself behind a cold hydrogen cloud from Earth's perspective. The star's radiation excites hydrogen atoms in the cloud. These excited atoms create conditions for stimulated emission. The hydrogen cloud transforms into a natural amplifier, similar to a maser. Like a cosmic lighthouse beam sweeping across our planet, this stimulated emission would create an extremely narrowband signal, exactly matching the WOW detection. The process would amplify the radiation to many times its normal intensity, explaining why the signal was so much stronger than background noise. Because this emission would be directional rather than omnidirectional, it creates a focused beam that might briefly sweep across our solar system. This alignment of a star behind precisely the right kind of hydrogen cloud would be extraordinarily rare, explaining why the signal was never detected again. It requires a perfect combination of cloud density, temperature, and excitation energy, conditions that might occur only once in decades for any particular region of space. The research team supported their hypothesis with observations of similar, though less intense, narrowband signals detected near the hydrogen line frequency in other parts of the sky. Using more sensitive equipment than was available in 1977, they identified several transient emissions that shared characteristics with the WOW signal, though none matched its intensity. What makes this hypothesis particularly compelling is how it accounts for all the observed characteristics. The narrowband nature, one of the most difficult aspects to explain through natural phenomena, emerges naturally from the stimulated emission process. The signal's frequency being slightly offset from the exact hydrogen line could be explained by the relative motion of the cloud. The perfect 72-second duration matches what would be expected from a fixed-point source as Earth rotated. And the one-time appearance makes sense given the rare alignment required. If correct, this hypothesis would mean astronomers had recorded the first known instance of an astronomical maser flare in the hydrogen line. Masers had been observed in other molecules in space, particularly water and hydroxyl, but never before in atomic hydrogen at the 1420 MHz frequency with such narrowband characteristics. The implications extend beyond explaining the WOW signal. If hydrogen clouds can occasionally produce strong, narrowband emissions at near the hydrogen line frequency, this creates a new source of potential false positives in SETI searches. The very frequency range that SETI researchers have focused on as the most logical choice for extraterrestrial communications might occasionally be filled with natural signals that mimic artificial transmissions. This doesn't invalidate the logic of searching near the hydrogen line for alien signals. It reinforces why both natural and artificial sources might choose this frequency. It represents a fundamental physical constant of the universe. But it suggests that SETI researchers need more sophisticated criteria to distinguish between natural maser events and potential artificial signals. The 2024 research has opened a new era of investigation but hasn't definitively proven this explanation. Critics have noted that the model needs more detailed physics to demonstrate exactly how a hydrogen cloud could produce such an intensely narrowband emission. Others question whether the energetics would work, whether a typical star could provide sufficient excitation to create a maser of the required strength. Some SETI researchers express a bittersweet reaction to this potential natural explanation. While scientific progress demands following the evidence, many had hoped the WOW signal might represent actual extraterrestrial contact. Finding a natural explanation removes some of the wonder that has surrounded this signal for nearly 5 decades. Others note that even if the WOW signal is explained as a natural hydrogen maser, the search for extraterrestrial intelligence remains compelling. The fundamental questions that drive SETI, are we alone? Do other technological civilizations exist? Remain unanswered. The hydrogen maser theory simply removes one candidate signal while improving our ability to distinguish natural phenomena from artificial ones in future searches. Whether explained by natural phenomena or not, the WOW signal's impact on our search for extraterrestrial intelligence remains profound. It transformed SETI from a fringe interest into a legitimate scientific endeavor with dedicated instruments and research programs. It established protocols for signal verification that continue to guide modern SETI efforts. And perhaps most importantly, it demonstrated that the search for extraterrestrial intelligence involves concrete observations and testable hypotheses. Why we keep looking. The hallmarks of true science. Why does a single 72-second signal from 1977 still drive our cosmic quest? Since the WOW signal's discovery, astronomers have conducted dozens of dedicated follow-up observations targeting the same region of sky. These efforts began immediately after the initial detection, with Ohio State researchers reprogramming the Big Ear telescope to repeatedly scan the Sagittarius coordinates where the signal originated. The pursuit quickly expanded beyond Ohio State. Multiple world-class observatories joined the chase: the Very Large Array in New Mexico, the Green Bank Telescope in West Virginia, the Allen Telescope Array in California, and the Arecibo Observatory in Puerto Rico before its 2020 collapse. Each brought increasingly sensitive technology to bear on the mysterious coordinates. Amateur astronomers also mobilized, coordinating worldwide campaigns that target the region each August on the signal's anniversary. This cosmic hunt resembles chasing a ghost. The signal haunts astronomy with its tantalizing possibility while remaining frustratingly elusive. Despite thousands of hours of observation using equipment far more advanced than what existed in 1977, the signal has never reappeared. This absence of repetition constitutes one of the most puzzling aspects of the WOW mystery. If it originated from an extraterrestrial civilization, why hasn't it returned during follow-up observations? If it resulted from a natural phenomenon, why haven't similar events been detected in the same region? Scientists have proposed several explanations for this non-repetition. Perhaps it represented a one-time transmission rather than a continuous beacon, a cosmic hello, not meant for repetition. The transmission might use a rotating beam that only occasionally points toward Earth, with subsequent observations missing these brief windows. The originating civilization might broadcast intermittently to conserve energy, or Earth may have simply intercepted a signal intended for another star system. Alternatively, the signal might continue but has changed in ways that make it undetectable with current methods. The transmitter could have shifted frequencies, altered its pattern, or changed location. Interstellar medium variations might affect signal propagation differently at different times, rendering a continuing transmission undetectable during follow-ups. Despite the lack of confirmation, the WOW signal has profoundly influenced SETI research. Before 1977, SETI efforts were limited and often viewed skeptically. The signal demonstrated that methodical searches could potentially yield results, spurring development of more sophisticated initiatives. The NASA SETI program, launched in 1992, drew motivation from the possibility that signals like the WOW might be detected with advanced equipment. When Congress canceled NASA SETI funding a year later, private initiatives emerged. The SETI Institute's Project Phoenix, SETI at Home Distributed Computing Project, and Breakthrough Listen all trace their inspiration partially to the tantalizing possibility represented by the WOW signal. The emotional commitment of researchers to this mystery remains remarkable. Scientists have dedicated entire careers to examining this 72-second anomaly, driven by the fundamental question of whether we are alone. Modern technology has reinvigorated this quest, creating systems that would seem like science fiction in 1977. The Square Kilometre Array, under construction across Australia and South Africa, will monitor millions of frequency channels simultaneously across the entire visible sky. Search methodology has evolved substantially based on lessons from the WOW signal. Modern systems implement immediate follow-up protocols when candidate signals appear, triggering automatic re-observations within minutes rather than days to catch repeat transmissions. Many radio telescopes now use multiple receivers observing the same target simultaneously across different frequency ranges, allowing instant verification. This evolution addresses a primary limitation in the WOW investigation: the lack of immediate follow-up capability. Had the Big Ear telescope been able to automatically reorient when the signal appeared, we might have gathered critical additional data that could have resolved its origin. Within the scientific community, opinions remain divided on whether the WOW signal represents genuine extraterrestrial contact. Some researchers, including Jerry Emin himself, maintain that extraterrestrial origin remains plausible given the signal's characteristics. Others believe an unknown natural phenomenon is more likely, following the principle that extraordinary claims require extraordinary evidence. A confirmed detection of extraterrestrial intelligence would extend far beyond astronomy into philosophy, religion, sociology, and potentially every aspect of human thought. It would answer one of humanity's oldest questions while raising countless new ones. Who are they? How advanced are they? What do they want? Should we respond? Regardless of whether the WOW signal originated from extraterrestrial intelligence, a natural hydrogen maser, or another phenomenon, its legacy is secure. It transformed SETI from a fringe interest into a mainstream astronomical research area with dedicated instruments and methodologies. The signal demonstrated that the search could be conducted with scientific rigor, generating testable hypotheses rather than mere speculation. The WOW signal serves as a reminder of how much we still have to learn. After 47 years of investigation by hundreds of scientists using increasingly powerful instruments, we still cannot definitively explain those 72 seconds of unusual radio waves. This humility in the face of cosmic mystery drives scientific progress, pushing us to develop better theories, build more sensitive instruments, and continue asking fundamental questions about our place in the universe. As we stand at this cosmic crossroads, the WOW signal reminds us of both the possibility and challenge of confirming we are not alone. The universe is vast, and our search has barely begun. The quest continues, driven by the same curiosity that made Jerry Emin write "Wow" on a computer printout on a summer day in 1977. The human element, why we need to believe. What does our fascination with the WOW signal reveal about humanity itself? While astronomers debate hydrogen masers and frequency analyses, something more fundamental is happening in how the public has embraced this 72-second radio burst. The WOW signal has transcended its scientific origins to become a cultural touchstone, a symbol that represents our collective hope that we are not alone in the universe. The signal has permeated popular culture extensively. It appears in television shows like The X-Files and The Big Bang Theory, features in novels, comic books, and video games. Musicians have composed experimental electronic works translating the 6EQUJ5 sequence into sound patterns. A craft brewery created a WOW signal beer with the recipe encoded in binary on the label. This cultural penetration is remarkable considering it stems from 6 characters on a computer printout from 1977. The WOW signal stands apart from other SETI candidates. Similar signals have emerged over decades. The radio source SHGB02+14A, discovered by SETI at home in 2003, fast radio bursts, detected in 2007, and the BLC-1 signal from Proxima Centauri identified in 2020. Yet none has captured public imagination with such enduring power. Timing contributed significantly to its impact. The signal appeared months after Close Encounters of the Third Kind's release and during Star Wars development, amid a renaissance in science fiction that prepared the public for potential alien contact. The Cold War backdrop made the prospect of cosmic intelligence particularly appealing as an alternative to earthly conflicts. The name itself amplifies the signal's resonance. WOW conveys immediate emotional impact rather than clinical designation. Jerry Emin's spontaneous margin note personalized the discovery, transforming data into story. The signal occupies a unique position between scientific credibility and mystery. The WOW signal sits in a Goldilocks zone for public interest, explains Dr. Margaret Whitecamp, curator of space history at the Smithsonian's National Air and Space Museum. It's credible enough for mainstream science but mysterious enough to sustain decades of speculation. Psychologists suggest our fascination with this cosmic invitation stems from deep human needs. We seek confirmation that we're not alone, both literally in finding other civilizations and existentially in finding meaning beyond Earth. Potential extraterrestrial contact offers cosmic validation. If other intelligences exist and find us noteworthy, perhaps our existence has significance beyond our own. Assessment. Dr. Albert Harrison, who studied societal implications of astronomical discoveries, observed that potential alien signals address what he called cosmic loneliness, our sense of isolation in an apparently empty universe. The WOW signal, with its tantalizing characteristics, serves as a vessel for our hopes that someone else is reaching out. Anthropologists note that nearly every human society has developed myths about non-human intelligences, from angels and demons to spirits and gods. These cultural frameworks provide cognitive templates for conceptualizing extraterrestrial beings. The wow signal, without imposing specific alien characteristics, allows individuals to interpret it through their cultural lenses. The signal's unresolved nature creates engagement through what cognitive scientists call ambiguity tolerance. For many, this mystery generates more sustained interest than a definitive explanation would. The ongoing questions allow continuous speculation in ways that a final answer might actually diminish. Dr. Jill Tarter, former director of the SETI Institute and inspiration for Ellie Arroway in Contact, observes this deeper connection. When people learn about SETI, they're interested in what it would mean for humanity if we found we're not alone. Her work emphasizes how the search itself reflects profound human questions about our cosmic significance. The signal serves as a mirror for how we view ourselves. Optimists see it as evidence that technological civilizations might survive their development without self-destruction. Religious thinkers find compatibility with their understanding of creation, while others view it through lenses of technological progression or cosmic community. Our relationship with the wow signal reveals our complicated stance towards scientific authority. Many embrace the mystery because expert consensus remains divided. In an era of fluctuating institutional trust, unresolved scientific questions create a democratic intellectual space where amateur theories coexist with expert analyses. Surveys show most people believe confirmed alien contact would be among history's most significant discoveries, potentially triggering social and philosophical transformations. Yet paradoxically, these same respondents don't believe such a discovery would significantly change their daily lives or personal beliefs. This contradiction highlights how the signal reflects our deepest hopes about our cosmic place. We want confirmation we're not alone while maintaining our sense of human uniqueness. The signal allows contemplation of contact without requiring us to fully confront its transformative implications. Dr. Stephen Dick, former NASA chief historian, argues that confirmed contact would constitute a Copernican revolution in our worldview. The wow signal allows us to rehearse this possibility from a safe distance, considering implications without immediate cultural shock. Perhaps the signal's greatest contribution is how it democratized cosmic questions. Before 1977, contemplating extraterrestrial intelligence remained largely confined to scientific institutions and science fiction. The wow signal brought these questions into news programs, classrooms, and dinner conversations, making SETI tangible to millions. As we conclude our investigation, we see that beyond scientific implications, the wow signal transformed how we collectively imagine our cosmic future. Whether eventually explained as hydrogen masers, alien transmissions, or something yet unconsidered, those 6 characters, 6EQUJ5, and Jerry Emmons' handwritten wow have earned a permanent place in humanity's conversation about our place among the stars. After 47 years, the wow signal remains a cosmic question mark. Neither definitively explained nor dismissed, it stands as a reminder of how much we still don't understand about our universe. The hydrogen maser theory and extraterrestrial possibility create a tension that drives scientific progress forward. Those 72 seconds in 1977 transformed SETI from fringe science to mainstream astronomy, pushing researchers to develop better detection methods and rigorous analysis techniques. The signal's greatest legacy lies in how it inspires us to keep listening, creating a moment when scientific dedication meets cosmic mystery. We continue watching the stars, waiting for the next time someone might circle